Hi, MYP3. So I'm here again, redoing that video with the mic on this time to show you what working out should have been done for your Criterion B assessment. Please make sure that you either reprint your assessment and write on the paper, or you can write in the Google Doc if you prefer that, and turn it in via your classroom assignment when you're done. So the first question here, you simply had to fill out those gaps. And the first one, 2 squared minus 1 squared being equal to 3, is done for you already. The second one, 3 squared minus 2 squared is equal to. So you can either use the space here to do your writing out, or you can just simply do it right there. So 3 squared is the same as 3 times 3 being 9, minus 2 squared is 2 times 2, giving us 4. 9 take away 4 gives us 5. And the second one, 4 squared minus 3 squared. 4 squared is the same as 4 times 4, being 16. Take away 3 squared. 3 times 3 is equal to 9, and that's equal to 7. So that's all that you had to do for that first question, A. B. Here it asks you to investigate the differences between consecutive square numbers. Consecutive means numbers that are added by 1. So 1 plus 1 is 2, plus 1 is 3, plus 1 is 4, plus 1 is 5. So 1, 2, 3, 4, 5, 6, 7, they are consecutive numbers. And consecutive square numbers are written down here. So 1 is is 1 squared. So it's 1 to the power of 2. 4 is the same as 2 to the power of 2. 9 is the same as 3 to the power of 2. 16 is the same as 4 squared. And 25 is the same as 5 squared. So you should be able to memorize those first, I would say, up to 10 square numbers. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, up to 10 at least, usually actually up to 12, but that's fine. So now let's have a look. You didn't have to look at now these numbers and search for a pattern, but it asks you here to look at the differences between those square numbers. So let's have a look. The first one is 2 squared, take away 1 squared, which is the same as 4 minus 1, and that's the same as 3. So that first one here, that first difference is 3. Second one, 3 squared, take away 2 squared, being the same as 9, take away 4 is equal to 5. So that second difference here is 5. Next, 4 squared, take away 3 squared is the same as 16, take away 9, being equal to 7. So that's that third difference here. And finally, we have 5 squared, take away 4 squared, being equal to 25, take away 16, being equal to 9. And now when we're looking at these numbers here, I'm going to highlight those for you in maybe yellow. We're looking at these numbers. These are the differences. Then we notice a few things. And so one thing, and none of the things that you investigate here, as long as they're based on your findings, and you see the pattern there and describe it, it's not going to be wrong, okay? Only if your numbers show something else than as you describe, then you can't get the marks there. So the first thing is that you notice could be that all of these are odd numbers. The second thing that you could notice here is that you add 2 each time. So these are the two main findings that you could have done here. Some of you have also noticed that it's exactly the number of squares in that white pattern here. Yeah, so that's also something that you could have noticed. I'm going to write this down here. The answer is equal to the number of white squares. Right. So these are patterns that you could have found here. Another one would also be, some of you might have seen that when you add 2 and 1, you get 3. When you add 3 and 2, you get 5. 4 and 3, 7. 5 and 4, 9. That could have been another pattern that you could have investigated. No matter which pattern it would have been fine. So now using your pattern to predict the next answer. And actually, I'm not sure it was this question, but actually we have done that here already. However, it says here, use your pattern. So if your pattern was add 2, then 5 squared minus 4 squared would be the same as the previous difference here is 7. So in this case, your pattern would say it's 7 plus 2 being equal to 9. So let's check. 5 squared is 25. Take away 4 squared is 16. And that's equal to 9. And you would have shown that actually your pattern was correct. That's one way of doing it. Yeah? Question 2. First thing you again had to do is fill out the missing gaps. Number 1 here is done for you already. 3 squared take away 1 squared is 8. Second one, 4 squared take away 2 squared. So 4 squared is 16 minus 2 squared is 4, giving us 12 as an answer. And the second one, 25 is 5 squared minus 3 squared being equal to 9. 25 take away 9 is 16. And that's it for that question number 1. Question number 2 asks you again to investigate the differences between now alternate square numbers. So you're always skipping one. We're looking at this one and this one, not the one in between. We're looking at this one and this one, skipping the 9. So let's have a look here. Alternating square numbers. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So let's start with that first one. 3 squared, take away 1 squared, being equal to 9, take away 1, equal to 8. Next one, 4 squared, take away 2 squared, being equal to 16, take away 4, equal to 12. And next one would be 5 squared, take away 3 squared, being equal to 25, take away 9, which is equal to 16. Now, let's look at these. Oopsie, sorry. Actually wanted to highlight that, not delete it. So let's look at these numbers here. 8, 12, 16. What patterns could you describe here? You could say they're all even numbers. You could also say that you're adding 4 each time. So plus 4, plus 4. And there's several other things that you could have noticed here, all right? You could have again said, going back to that first one, that they're equal to the number, the answer is equal to the number of white squares here. Counting these squares gives you your answer. You could have said that. So that's the patterns that you could have found here. Now let's have a look at finding the general rule. And that was kind of tricky for many of you. So I was helping you out here a little bit, and I said that we're first of all looking at the area of this pink shape here. This pink shape. Now this pink shape here is made from one square with the side length of A. So that would be A. Let's call it, let's just call it A, being equal to A times A, which is A squared, right? Or I'm going to call it A1. And I'm going to call this here A2 because from this square, from the whole square, we now need to take away that tiny little bit here, that little square here. This little square has a side length of B. So the area of this A2 is B times B, being the same as B squared. So I told you that the area of that pink shape is equal to A1 minus A2, which is the same as A1 is A squared minus B squared. So that's what I told you already. And then the trick here was, in diagram 2, this part here is the same as this part here. And it's taken off this side and it's put right here on top of that rectangle to make a big rectangle here. And I told you that this pink area is equal to this pink area and that you should be using the area of a rectangle being calculated by length times width. And I said to you, your task is to find out what is the length and what is the width. So let's say this here is the length and this here is the width. Now let's look at this little rectangle here. Because it is the same as this rectangle here, what is this side length? Think about that for a second. This little length here, that's what I want to know from you. This little length here is equal to B. It's exactly the same as this side here. So that's B. So we just found out that this whole length here is A plus B. So that side length is A plus B. Now we need to figure out what the width of this rectangle is. This part here. And that was a bit trickier to find out. So this part here is the same as this part here. I might take a marker and mark this with, let's say, dark pink. Okay, so we're looking here. Maybe dark pink was not the right choice. Let's take orange. That's a bit more contrast to the pink that is already there. So this length here, this one here, is the same as this one here. They're equal. Yeah? It's the same rectangle, so those two are equal. Now let's have a look if we can find out what this side length is. So this whole length here is the same as this one. And that's A. So I'm going to write this down here. This whole length here is A. But we don't want that whole length. We just want this part here. So what is this part here? Well, it's this tiny little bit shorter than A. So let's think about what is this tiny little part here? What is it? So this part here. What is this part here? This part here is the same as this part here. This one and this one are equal. This one and this one is equal. What is this one? It's B. Yeah. So this tiny little bit here is B. So the length of this width here, which is the same as this one here, is A minus B. We're taking this little part away from that whole length to find this part here. And I'm going to write this down for you right here. So the width of this rectangle, this width is the same as this length here. And this length here we just found out is A minus B. So the general rule that you should have found out here was that A squared minus B squared is the same as A plus B times A minus B. And if you're using the FOIL method, it is quite easy to go backwards and to check if your findings are correct. Yeah. I might actually do that on a separate page. so that you can see what I'm talking about. So we have just written down that a squared minus b squared is the same as a plus b times a minus b. And when we're using that FOIL method that you have learned, FOIL means first, which is a times a being a squared, then outside, O outside, these are the outsides, a times negative b gives us negative ab. Then we want to do the inside, which is b times a, which is the same as ab. So plus ab, and finally we have the last here, b times b giving us b squared. So let's have a look. This one and this one together, when we were using the algebra tiles, we called this a zero pair. So this is 0. If I have AB and I take away AB, then I'm left with nothing. So what I have left here, and by the way, I made a mistake. Who can spot my mistake? Right here. Because B positive times B negative gives us a negative B here. Yes. So what we're left with here is a squared take away b squared. And that's exactly what we started with. So we found out using the FOIL method that this indeed is equal to that. It was not a requirement in the paper at all. It is just for you to show how you could have used what you learned already to check your answer. Now it says here, verify and justify your findings by applying your rule to one problem each from 1a and 2a. So I am going to pick this one for 1a. 3 squared minus 2 squared. So 1a. 3 squared minus 2 squared. And I should now apply this rule to this question. So I'm going to write this out here. A squared minus b squared is equal to a plus b times a minus b. So if my a squared minus b squared is 3 squared minus 2 squared, then my a is 3 and my b is 2. So I've got here 3 plus 2 times 3 minus 2 equal to. And now one very important thing that you must not forget to use is BIDMAS. We're starting here with the brackets. And the brackets say that 3 plus 2 give us 5 times 3 minus 2 is 1, being equal to 5. And this is exactly what we got on that first page in this question. And what I'm going to do next is I'm going to redraw this here right there. I'm probably not going to have enough space, so I'm going to make this quite small. So it looked something like this. We had 3 and 2, and there was that 2 by 2 square taken out. Now, comparing it to our diagram up here. Yeah, in particular, this one here. So this is the square I am taking out from that first square. And this is equivalent to this one here. Now, if this square is this square down here, then this little rectangle must be the same as this rectangle here. And therefore, I can redraw this one, shifting the rectangle from here to here. This rectangle is going here. I'm going to show you why this is important. So I have this part here. I'm going to redraw it. So I'm just looking at this part. And this is the same as drawing it out like this. All I've done is I've taken these two and put them up here. And why is that interesting? Because when you look at the area of this rectangle now, this is a simple rectangle, right? And this rectangle has a length of 5 and a width of 1. And that's what we calculated here. This length is 5 and this width is 1. So we calculated here the area of this rectangle. So that was from question 1a. I'm going to do question 2 here. So that would be question, I think yours were labeled differently, but that's 3b from what I have here. And I'm going to choose one question from 2a. I am actually going to draw out this one, 5 squared minus 3 squared. So, 5 squared minus 3 squared is equal to. And I'm going to use again this rule that we found. So a squared minus b squared is supposed to be a plus b times a minus b. Now let's see if that's right for our problem. So if a squared minus b squared is 5 squared minus 3 squared, then this must be 5 plus 3 times 5 minus 3 equal to, don't forget, BIDMAS, really important. Never forget BIDMAS. So the first bracket first, 5 plus 3 gives us 8. Second bracket next. Don't forget the times in between because there is a times in between here as well. 5 minus 3 gives us 2. 8 times 2 is 16. Going all the way back to check my answer. Here, I also got 16. So that's verifying my findings. And again, I'm going to draw this out. So I have got here something that looks like this. And like this. And there was a square taken out here. That was 3 by 3. So just to clarify, I first had a square that was 5 by 5, 5 squared, and I'm taking away a small square that is 3 by 3. And just like here, I have this big square, taking this away, leaving me with this rectangle here, this one, that I can put on top here. And that's exactly what I'm going to do. I'm going to take this rectangle here and I'm going to put it on top here. So this one will become something that looks like this. 1, 2, 3, 4. There we go. So I've taken this part here and put it up here. And I get a rectangle that has a length of 8, which you can find here, and a width of 2, which you can find here. Yeah, so that's the geometric findings that we could have seen in this work. And that's it for your Criterion B. Please make sure that you fill out your Criterion B again, either by hand if you print it out at home, or you could also write on Google Docs directly. That's up to you. Please make sure that you submit it when you're done so that I can see that you have gone through this assessment again. Thanks for watching, and I'll